In this session we will see some more application of Biot-Savart law. If you see the last class notes, you may find how to find out the magnetic field at the axis of a circular loop, at any point on the axis of a circular loop. Now today we will find out what is the magnetic field at the center of a circular loop carrying some current I. First we will take down one question, and based on that question only we will try to find out the field at the center of a circular coil. Take down this. A circular coil of radius r, carries a current I. Write the expression for the magnetic field, or find the expression for the magnetic field. Find the expression for the magnetic field due to this coil at its center. Find out the direction of the field. Find out the direction of the field. A circular coil of radius r carries a current I. Find the expression for the magnetic field due to this coil at its center. Find the direction of the field. We know to find out the magnitude of the magnetic field, we have to use Biot-Savart law, and the direction can be obtained using right hand screw rule. In the last class I have explained you how to find out the direction for different directions of current. What is the direction of the magnetic field? We have found it in detail. So to find out the direction, if you have any doubts, you can refer the previous class videos. Now let us consider a circular loop for this. It's given a circular loop and radius r. Let this is center, and from the center the radius is r. To apply Biot-Savart law, what will we do is we will take a small current element, say dl, and let us assume they have not given the direction of current. We will assume some clockwise direction, the current I, and let us say this is a small current element dl. dl is the small current element, and r is the radius. Consider a circle of radius r, circular loop of radius r, and in that circular loop I'll write this clearly. Let me draw it once again. We will assume the direction of the current as clockwise I, and the radius of the circle is given as r. To apply Biot-Savart law, what will we do? We will consider a small current element, say dl. You can write, consider a small, let dl as the current element, small current element. Small current element, and we know r is the radius of the coil. and I is the current to the coil. Now by Biot-Savart law we can write the magnetic field at the center due to the current element. By Biot-Savart law, the magnetic field at the center due to small current element dl is given by, we know, dB is equal to mu naught by 4 pi into ideal sin theta. Theta is the angle between the current element and the distance vector, dl and the distance vector. Now if we take here theta is 90 degree. Therefore sin 90 divided by distance square, and this gives us the magnitude. This is due to one small current element. Now if you simplify this, you will get dB as equal to mu naught by 4 pi sin 90 is 1, so it is ideal by r square. Therefore the net magnetic field at center, what you can do is you can consider small current elements, then you can add them together, or you can get by integrating over the circumference. So net magnetic field, I will write here only, net magnetic field at the center is given by B equal to mu naught by 4 pi I dl divided by r square Now you can take out the constant outside the integration. Mu naught by 4 pi into I divided by r square, mu naught by 4 pi into I by r square dl. This integration over the circumference dl, so it is nothing but equal to 2 pi r. When you add dl all small elements, you will get the total circumference of the circle, which is equal to 2 pi r. Mu naught divided by 4 pi into I divided by r square into 2 pi r, because for a circle dl, integration of dl equal to 2 pi r. Now simplify this. 1 r will get cancelled. We will have 1 r will go. B equal to mu naught by 4 pi mu naught by 4 pi into I by R. Mu naught by 4 pi into I by R into 2 pi. Again we can cancel pi and 1, 2 and 2. So finally we get B is mu naught I by 2R. B equal to the net field at the center. B is equal to mu naught I divided by 2R. Mu naught I by 2R. The field at the center of a circular loop B is mu naught I by 2R. Now if there are n turns, we can write here the magnetic field at the center of a circular loop of radius R carrying current I is magnetic field at the center of a circular loop of radius R carrying current I is given by B equal to mu naught I by 2R. Mu naught I by 2R. Now the direction can be found using the right hand grip rule. Because we have assumed a clockwise current in this case, the direction of magnetic field will be perpendicular to the plane and directed inward. The direction can be found using right hand grip rule. The direction of magnetic field is perpendicular to the plane of the paper and directed inward. And also take a note, if you have n turns in the coil, for coil with n turns, for coil with n number of turns, the magnetic field at the center will become B equal to, you have to multiply the above equation by n. This is with one turn, and if you have n turns, it will be mu naught Ni. Mu naught n into I divided by 2R. For coil with n number of turns, the magnetic field at the center B will be at the center as B is equal to mu naught Ni by 2R. This is how we find the magnetic field at the center of a circular current carrying loop.